Math 2, we're going to review the concept check, quadratics, investigation 1, lesson 3, investigation 2. So I would have your test handy in front of you so that we can go ahead and redo some of these problems together. So we're going to start with number 1, and number 1 for the problem says to factor each equation completely. So factor means that we want to make sure it looks like a multiplication. Okay, so if I ask you for factors of the number 6, you would say 2 and 3, because 2 times 3 equals 6. So I want to find two things that are going to equal each other and give me x squared minus 16. Well, this is something that we've been practicing a little bit during the warm-ups this week. Because if you notice x squared, that's a perfect square, and 16 is a perfect square, and here we have a difference. So we have the difference of squares. And so when I factor something that's special, like the difference of squares, where my constant term is a perfect square and my quadratic term is a perfect square, it follows a special pattern. And in fact, the pattern is that it's the product of conjugates. So I'm going to go ahead and set up my parentheses. And I know that the square root of x squared is x. The square root of 16 is 4. So in both places, I'm going to have an x and a 4. And since they're conjugates, one's going to be a minus and one's going to be the plus. And the reason for that, I'm going to kind of pull this off into the side, is if I have x plus 4 and I have x minus 4, when I go ahead and I multiply this out, and in fact I do my distribution, I would have x times x, which would give me x squared. I would have x times negative 4, which gives me negative 4x. I have positive 4, whoops, let's do that in green there, positive 4 times x, which gives me a positive 4x. And then finally, a positive 4 times a negative 4, which gives me a negative 16. Notice that when I have conjugates, that my linear terms are opposites of each other, and so they cancel out. So here I get my x squared, because that remains. My linear terms canceled out, and I'm just left with negative 16. And that's your check to make sure that you factored correctly. So I notice that that's exactly the same. Now there's a bunch of different types of factoring. So this one did not have a linear term, so no linear term. And so when I have no linear term, I want to look to see if there's a special property about it, like the difference of squares. For number 1b, this one has no constant term. No constant term is a nice, easy one to factor, because for this one, all I need to look is, what do these terms have in common? In fact, what's divisible into both of those terms? So what goes into both 2x squared and 8x? Well, what goes into both of them, and I'm going to start with a y here, is a 2. So 2 goes into both 2x squared, and it also goes into 8x, and also an x. And then I look what's left over. So 2x goes into 2x squared, and I just have an x left over. 2x goes into 8x 4 times, and it's a positive 4. So therefore my answer is y equals 2x times x plus 4. Well, again, we can try it out on the side just like we did with the last one. So I got y equals 2x times x plus 4. So I start with 2x times x, which equals 2x squared. Then I have 2x times 4, which equals 8x. And so I noticed that it's exactly what we started with. So that's our check. And that's factoring. So for number 2, what we wanted to do is we wanted to expand. So remember when we have something in factored form, since factored means multiplication, is something that'll look like something multiplied times something else. Or y equals x times x plus 1. That's factored form because I've gone ahead and I've completely factored, I've pulled it apart into its multiples. Expanded form, on the other hand, is something that is completely multiplied out. So it looks like a sum or difference of terms. So here I would have 2x squared, and then I would have 9x plus 4. That would be expanded form. Or y equals x squared plus x. Notice it's a sum or difference of terms. It's completely multiplied out. So looking at this first one, if I want to go ahead and expand it, well, hopefully you notice that this looks exactly like 1a's answer. But if not, we can go ahead and multiply it out. So we have x times x, which is x squared. Then we have x times 4, which gives us a positive 4x. Negative 4 times x, which is a minus 4x. And then finally a negative 4 times a positive 4, so a negative 16. Now you could save yourself a bunch of work by noticing that they were conjugates of each other also. But if not, multiplying them out wouldn't be a bad thing. Your linear terms are opposites of each other, so you're just left with x squared minus 16. So you have your quadratic term and your constant term. Okay, this right here up top, I'm going to kind of highlight it here, is just an expression. Notice there's no equal sign. That's a little different from this that had an equal sign, so it was y equals something. So here we just had an expression, and notice that's also in the directions, it's just an expression. So if you had written your answers as y equals that, well, we don't know that, it's just an expression, and we need to combine all like terms. Finally, in 2b, we have 6 plus x, and that's squared. So off to the side here, I want to think about whenever I have something squared like x squared, if I was to write that out, that would be x times x. If I had 2x squared, that would be 2x times 2x. So here I have 6 plus x squared, so it's going to be 6 plus x times 6 plus x. Now that I've written it out as a product, I need to go ahead and multiply it. So I have 6 times 6, which is 36. 6 times x, which is 6x. X times 6, which is, again, 6x. And then finally, x times x, which is x squared. Now, I could leave it like that, and that's a correct answer, except for the directions say combine any like terms. So now I want to write this as, and I'm going to kind of move over here to the side, 36 plus, now my like terms here is 6x and a positive 6x, so that's a plus 12x plus x squared. So that's problem 1 and 2. Look for the next video where I continue on with number 3.